Biyahe po kami from Davao City to here. Considering na malakas yung lindol, wala ho masyadong visible na damage. Bakit ho kaya? Despite the two doublet daw ho, dalawang malakas na lindol.
I cannot say.
Pero bakit ho?
I cannot say. Well, awa ng Diyos. Awa ng Diyos. Okay tayo dito.
Naniniwala ang isang structural engineer na kakayanin ng mga high-rise sa gusali tulad ng mga condominium at mga office building sakali magkaroon din ng malakas na lindol dito sa Metro Manila.
I would say na yung condominiums and office buildings, mostly high-rise structures, are generally safe in terms of structural design. Sa mga high-rise buildings, gumagamit na tayo ng mga shear wall, okay, ito yung mga buhos ng mga pader na tumutulong para ma-resist ng mga mataas na building yung mga malalakas na lindol.
Sabi ni Engineer Ronaldo Ison, posibleng mas ligtas pa mga high-rise building kumpara sa mga mabababang estruktura, lalo kung hindi ito na-inspeksyon. Para matiyak na ligtas ang tinitirahan o pinagtatrabahuhan na gusali, pwede raw hingin sa building administrator o developer ang mga dokumentong makapagpapatunay na dumaan ito sa tamang inspeksyon.
Good morning. I'm Rannie Ison, Ronaldo Ison. I am the Principal Structural Engineer of RS Ison & Associates. I have been practicing for the last 37 years as a structural engineer. I've been doing different projects locally and I have done projects also abroad. I specialize in vertical structures, mga high-rise buildings, medium-rise, and other different vertical structures. First and foremost, the Association of Structural Engineers of the Philippines is involved with the development of the NSCP since the first edition. We now have the NSCP at its 7th edition, NSCP 2015. So this NSCP is largely based and adapted from the American standards that are available and current at this time. In terms of international standards, the NSCP keeps our structural engineers abreast of the requirements in designing different structures, particularly vertical structures like low to mid to high-rise building structures. So this gives us information and guidance to perform a thorough structural design of the buildings. Sa present NSCP 2015, we determined the earthquake force based on the distance to the fault and then kung ano yung soil type and then kung ano yung type of structure that we're using. And then some other factors like the importance factor, which is kung ano yung usage of the structure. Specifically for Downtown Premier and Destine projects, we got the distance to the fault, and then we're able to determine kung ano yung strength ng earthquake. So for both Downtown Premier and Destine, we use a Type A seismic source na fault. So itong seismic source na to, the fault, can generate magnitude 7 to 8.4 earthquake. So therefore, itong mga buildings na to are designed for that strong earthquake, 7 to 8.4, based on the NSCP. And then we also did yung investigation ng soil dun sa where the site is. So based on our investigation, the soil is generally soft, so we need to provide board pile foundation. So for both Destine and Downtown Premier projects, we are using board piles to carry the building. The Destine and Downtown Premier buildings were analyzed and designed in accordance with the latest structural code, which is NSCP 2015. Furthermore, we have also taken the initiative to check these buildings with the forthcoming new seismic code provisions of the NSCP 2025. These new seismic provisions is a result of the latest studies of FIVOX on Mindanao earthquakes and the studies of ASEP on more advanced seismic design standards. The present NSCP also requires developers and designers to put in earthquake recording instruments. Ang tinatawag dito yung ERI. So, what does the ERI do? Ito yung equipments or devices that measures kung ano yung earthquake, vibrations, acceleration, velocity. These equipments that are installed in this building sa Downtown Premier tsaka sa Destine, these equipments measure yung effects ng earthquake. So with these equipments, yung building administrator ng Destine and Downtown Premier in the future, they will be able to know ano yung movement ng building during the earthquake that happened. So ngayon, with this information ng movement, acceleration, velocity ng building, the building can be checked if yung existing code or the design that was used by the engineers are still followed or are met. No? So magkakaroon tayo ng parang ECG of what's in the building. So with this, the building administrator would be able to also consult the engineer, consult me, and check, and we will be able to check our design if the building did not exceed yung assumed natin na earthquake forces. No? So this would help the building administrator and myself to be able to check yung integrity ng building. All these devices also would help, no? It would also show kung anong intensity ng earthquake that has occurred dun sa building immediately after the earthquake. My design philosophy is at all times we should be following the code, no, in terms of design, and it is proven that when we follow the building code, when we follow the National Structural Code of the Philippines in our design and construction of buildings, these buildings will be able to sustain very strong earthquakes and strong winds. No? These codes are also the products of researches and actual experiences during these calamities. No? So I would say that in our case, no, we always follow the code, and then we always ask the contractors and the developers to implement the plans and material specifications that are required in these drawings. No? So also, isa pang design philosophy is we should never go substandard. We should always meet the requirements of the code or even go higher than the requirements of the code, even if it would require a more expensive building. As a minimum, dapat we should be complying with the code requirements, and then we optimize the design, and we make sure that all the building components would properly interact and behave as we want during these types of calamities.